Hey, how's it going? So again, we're going to talk about now what makes something not a linear function. So again, just a recap, we were talking about how for something to be a linear function, its ratio of the change in y divided by the change in x coordinates must constantly be the same thing, because what makes something a linear function is the fact that its rate of change within the function is constantly going to remain the same. So if we take a look at this function, I'm going to go ahead and do this as normal. I will do what is it to change from the y function. The delta y from 3 to 5 is plus 2. From 5 to 8 is plus 3. And from 8 to 9 is plus 1. Now, it's important. Just because you got different numbers over here, this is a 2, this is a 3, this is a 1, does not automatically mean that it's not a linear function. What you need to check is also what is the rate of change for the x, because it's a ratio that disproves or proves that something is a linear function. So let's take a look. So from 1 to 2 is plus 1, from 2 to 3 is plus 1, and from 3 to 4 is plus 1. So what I now have is a bunch of ratios. So the ratio I have here is 2 divided by 1 is 2. But all of a sudden when I come down here and I do 3 divided by 1, I get 3. So this ratio up here of 2 divided by 1 does not equal the 3 divided by 1, which means that I have a changing rate of ratios, which means that this cannot be linear, because linear functions will have a constant rate of change. Therefore, for our purposes, we cannot create a linear function for this, but it doesn't mean that it's not a function, because remember, a function means that there is no repeating x input that has a different output. And up here, there is no repeating x with different outputs, so therefore it is a function. It just isn't a linear function. So for us, we're not going to write any equation. We're just going to write that this is not a linear function. Algebra 2 is where you'll talk about how can I create functions from this type of data.